Hey everyone, welcome to this new channel. This video will be covering the first half of OCR AS Chemistry, June 2024, Paper 1. If you do find this video useful, please give it a like and subscribe. First question is which diagram shows a p orbital? These are dumbbell shapes, so the answer is C. Question 2 is which row shows the atomic structure of Mg2+, isotope 25? On the periodic table, magnesium's atomic number is 12, so that means 12 protons. Right, and if it's 2+, that means 2 electrons are lost, leaving us with 10 electrons, so the answer is also C for this one. Question 3 is a nitrogen oxide contains 36.84% of nitrogen by mass. What is the empirical formula of the nitrogen oxide? So nitrogen's 36.84. There's only 2 elements present, so if you subtract this from 100, we'll tell you the percentage of oxygen, and that is 63.16. Then if we divide by the MRs, we can calculate the moles. So for nitrogen, that is 2.63. Oxygen is 3.9475. Then if dividing it by the smallest mole number, which is nitrogen in this case, that's 1. This one's 1.5. Then we want to get it to a whole number, so you can times by 2, leaving us with N2O3. So it looks like the answer is option D. Question 4 is carbon monoxide reacts with oxygen to form carbon dioxide. Which volumes of carbon monoxide and oxygen produce the largest volume of carbon dioxide? All gas volumes are measured at RTP. So this question doesn't really require any calculations. You just have to find the limiting reagent and thus use the molar ratio to figure it out. So if we look at each of the options, in the first option, the limiting reagent is carbon monoxide. And the reason why we know this is because the molar ratio between carbon monoxide and oxygen is 2:1. So because we've got 1 decimeter cubed of this, the minimum of oxygen that is required is half of it, which is 0.5. Now we've got 4 decimeters cubed, which means that oxygen is in excess. So that's a limiting reagent, carbon monoxide. The next one looks to be carbon monoxide is limiting as well, because the minimum required for oxygen would have been half of this, which is 1. Next option, similar story. It is carbon monoxide that's limiting, because the minimum required for oxygen would be 1.5, but we've got a lot more. In option D, it looks like the limiting reagent is oxygen this time around, because the minimum we needed to react with 4 should have been 2. Okay, now that we know our limiting, the limiting reagent is going to dictate how much we're going to make of a product. So the product is dependent on the limiting. So for the first option, 1 decimeter cubed of limiting gives us also 1 decimeter cubed of carbon dioxide because it's a 2:2, or rather 1:1 ratio, so that's not the answer. Next one's not either because that's 2. Option C looks good because that looks like 3 decimeters cubed compared to option D, which is just 1 decimeter cubed, so answer is C. Question 5 is which reaction produces a product with a linear molecule? So this one would make BF3. That is linear. No, that's not linear. That is trigonal planar. Carbon plus oxygen, well, that would give us CO2. That is linear because the bond looks like this, and that's 180 degrees, so the answer is B. This one would make water. Water is bent, and this makes ammonia. Ammonia is pyramidal shape. Question 6 is which statement about the periodic table is not correct? Elements in the same group have similar chemical properties. This is true, therefore not the answer. Elements are ordered by increasing atomic mass. This is not true. It used to be true before, I believe, Mendeleev, I think that's his name, the Russian scientist. So it used to be increasing atomic mass, but then there are some changes. So for example, a change that we can see is between potassium and argon. So argon being heavier than potassium, they should have been the other way around, but that did not fit the chemical properties. Therefore, this was one example of a pair reversal. Well, bottom line is they're not ordered by masses, they're ordered by atomic number. So this is not correct, therefore the answer. The other 2 statements are correct. Question 7 is group 2 compounds can be used in agriculture to neutralize acidic soils and in medicine to treat indigestion. Which group 2 compound is not suitable for either use? So agriculture to neutralize soils and indigestion, this is both to neutralize acid. Yeah, like agriculture to neutralize acidic soils and indigestion to neutralize stomach acid. So the first one can be used because it is an alkaline or it's basic in nature. The next one, that one would not be used because this is a salt. Salts cannot neutralize acids, so that becomes a not suitable one. So the answer is B. Question 8 is in the UK, water companies typically treat drinking water with chlorine gas at a concentration of 0.5 milligrams per decimeter cubed or less. What statement about UK drinking water is correct? Chlorine in drinking water can catalyze the breakdown of the ozone? Not really, because in order to do that, it has to be in the air. This is in water, so no. Second one is chlorine may form toxic chlorinated hydrocarbons. Yes, this could be an issue, which is it's a carcinogenic compound, so it's a risk of causing cancer. So then that would leave us with B as the answer, as that is the only correct statement. Right, question 9 is which reaction does not show disproportionation of chlorine? Disproportionation is when the same element is both oxidized and reduced. So looking for chlorine so we're looking at not disproportionated. So in this one, chlorine's oxidation is -1. Over here, it's also -1. Over here, it's 0. So this is not disproportionation because we can only see it oxidized, but we cannot see it reduced. So yeah, the answer is A. So just showing you an example of how you could prove the other ones are disproportionation. So let's go with option B. So an element by itself is 0, and then in HCl it's -1, and HClO it's actually +1. And the reason why you can tell is hydrogen is always +1. Chlorine, that's the one we're finding, so that we could just leave as X. Oxygen is always going to be -2, and we could equate this to 0 because it's a neutral compound. Then if we use a little bit of algebra to solve this, X would be equal to +1. So you could use a similar strategy to work out the oxidations of chlorine in C and D, and that will show you why those two are also disproportionation reactions. Question 10 is an unknown compound is tested to identify whether it contains sulfate, carbonate, or halide ions. Which is the correct sequence of tests required? So the correct sequence would be carbonate first, second is sulfate, third is the halide ions. Reason being, for carbonates, we're not looking for any precipitates, we're just looking for a gas, carbon dioxide gas that you can bubble through lime water and then that turns cloudy. If you were to do the sulfate test first, sulfate test involves the addition of BaCl2, so barium chloride, and in the presence of sulfate, the barium ions react with the sulfate to make BaSO4, which is a white precipitate. Now, the issue is Ba2+ can also react with carbonate ions, also forming a white precipitate. Therefore, this would give you a false positive for the sulfate ion, which is why it must come second. And the reason why halides are third is because halides are tested with acidified silver nitrate. And the idea is silver would form a precipitate with the halide, so either chloride, bromide, or iodide, forming a colored precipitate which varies between yellow, cream, and white. Now, all of those colors being off-white is an issue because silver can also form a precipitate with carbonate and also forms a precipitate with sulfate. And both of these precipitates are whitish in color, which makes the halide ion difficult to distinguish, giving you false positives for that as well. So the only option that has that sequence is option B. So that's the answer. Question 11 is an enthalpy cycle is shown below. What is delta HR in kilojoules per mole shown in the enthalpy cycle? So enthalpy, or rather Hesse cycle by definition, is enthalpy is independent of the route taken. So we could go this way and then up this way to find delta HR. So going with the arrow, we can keep the sign the same. That's -393. And then this one, because we're going against the arrow, we can change the negative into a positive sign. So it becomes plus +283. And that is equal to -110. So the answer looks to be C. A way you can double check your answer is by adding all of the values together. If you get 0, that means that it was correct. Question 12 is a mixture of gases is heated in a closed container. The reaction rate increases. Which statement explains why the reaction rate increases? So that is more molecules have energy greater than activation energy. That does seem correct, but is there a more correct statement? So the next one is activation energy decreases. That is not true. Activation energy increasing is also not true. There's nothing that can change activation energy other than a catalyst, which is why those two are not the answers. And catalysts typically tend to decrease the activation energy anyway. And then option D is that the concentration of gases increases. This is not true because it's a closed container or closed system, and everything relatively stays constant. So the answer would have to be A. Question 13 is the reversible reaction below is at equilibrium. What is the expression for Kc? So Kc expression is usually products over reactants. So the product is SO3. The only option that has that is B and D. And the 2 in front becomes an indices, and now it becomes squared. The only option that has that is B, so that's the answer. Question 14 is what is the name of the compound below? So numbering it, the thing that gets priority is actually the alcohol, and the reason being it becomes the suffix. So it's always like 1-ol, 2-ol, etc. So if it's a suffix, it gets priority. So this would be a 1-ol, so that's carbon 1, carbon 2, carbon 3, and carbon 4. We're looking for the longest possible carbon chain. So the longest chain is 4 carbons, so it has to be a bute of sorts. So it's between options B and C. And we know that OH is on the first carbon, so C is automatically correct, but we can double check. So 3-chloro looks yes, chlorine is on the third carbon. The second carbon has a methyl group. That is also correct, so the answer is confirmed to be C. Question 15 is the structure of a hydrocarbon is shown below. Which terms describe this hydrocarbon? Alicyclic and saturated, not true. It is alicyclic, but it's not saturated because it has double bonds. B is aliphatic and alicyclic. Yeah, that would be true. Allocyclic because it's, well, cyclical. Aliphatic, I know in the textbook, especially the Oxford Press textbook, it says that aliphatic is usually straight-chained or branch-chained. But if you look at the OCR website, if you just Google it, on the OCR website, there's like this clarification post which mentions that alicyclic compounds are also aliphatic. I know, it's a bit confusing because it seems to be misinformation in the textbook, but I would always recommend you look at like the OCR clarification document thing, and it would make it very clear on that. Yeah, it's also surprisingly not on the OCR A-level specification. It's on like a separate page, which I feel like the exam board does that to sabotage students, but that's just my personal opinion. Yeah, but anyway, the answer is B, given that. The reason why it's not aromatic is because aromatic would have to be benzene, and that is having 3 double bonds that alternate between each other. Now, most of you watching this video are probably Year 12 students doing AS chemistry. Aromatic and benzene stuff is a Year 13 topic anyway. Question 16 is which property explains the low reactivity of alkanes? So the low CC bond enthalpy. Not true, because if it were low, it's easier to break, making it more reactive. So this is contradictory. Option B is low bond enthalpy of the pi bonds. Well, this is true, but it's true for alkenes, not for alkanes. Right, so this is also not the answer. Low bond polarity of the sigma bonds. Yes, this is true. The low polarity makes it not susceptible to other molecule attack. So the answer is C. Question 17 is the repeat unit of an addition polymer is shown below. What statement about this addition polymer is correct? Combustion produces toxic alkaline fumes? Not really. It would produce toxic acidic fumes because of the Cl. So you could make HCl as a toxic byproduct, and that's acidic. The addition polymer is biodegradable? Not true either. For it to be biodegradable, it has to be susceptible to nucleophilic attack. Now, I believe this might be probably Year 13, so if you haven't heard nucleophilic attack before in polymers, you could just ignore what I'm saying right now. When you come back to this in Year 13, it will make more sense. But bottom line is PVC, which is what this is, polyvinyl chlorine, it's not biodegradable. The monomer is this. Well, we could check that out. So if we put the double bond over here, that makes it a monomer. So it's CH3. Yeah, so this looks to be correct. Option C. And the reason why option D is not correct is in order for it to be a displayed formula, the CH3 at the top over here should have shown all of the hydrogen bonds. Just CH3 like this is structural, so it's a hybrid between structural and displayed. So again, the answer is C. Question 18 is which functional groups are present in the compound below? So this end is a carboxyl end, so it's a carboxylic acid. And that looks like a ketone, so option D. 19 is which statement about infrared radiation is not correct. So absorption of IR by molecules such as CO2, H2O, and CH4 is linked to global warming. This is a correct statement. So it is not the answer because we're looking at what's not correct. IR causes CFC molecules to produce chlorinated radicals. No, this is not correct because what produces radicals is actually UV, not IR. Because it's not correct, it is the answer. Question 20 is an alcohol. This one produces a mass spectrum. The mass spectrum contains a fragment ion at MZ45. What is the possible identity of this fragment? So looking at our options, the first one, if we find the MR, that would tell us the MZ value as well, and that is equal to 44, so that's not the answer. The one below that is 40. The one below this, so this one is 45, so it's a strong contender. But can we produce this peak? Not by the looks of it, because we've got two CH2s back to back. That is not possible on this, to have two CH2s together. So while this is 45, it's not possible, so it's not the answer. The one below it would be 45. So this seems like a contender. Can we have CH3? Yes, that's a CH3. That's a CHOH. Yeah, so that one is possible. So it's what it's saying, it is this peak. And that is probable for that to happen. So yeah, the answer would be C for this one. On to section B, question 21 is about iron. A sample of iron is isolated from a meteorite and analysed by mass spectrometry. The mass spectrum shows peaks with relative abundances below. Calculate the relative atomic mass of the iron in the sample. Give your answer to 2 decimal places. So relative atomic mass, or AR, is calculated by multiplying the isotope number with its abundance, added to the next isotope multiplied by its abundance, so forth and so on. So the AR over here would be equal to 54 times 78.54, or you could have already converted this into a decimal, but I will divide by 1,000 later. 100 divide by 100 afterwards, and then that plus 56 times 8.88 plus 57 times 5.1 plus 58 times 7.48. Divide by 100, and that would equal to 54.6298. So 2 decimal places, that would be 54.63 as the answer. Part B is iron can be extracted from iron ores containing oxide Fe2O3. What is the systematic name for this? So systematic name is based on the oxidation of iron. So the oxidation would have to be +3 in this case. So the idea is if Fe is 3 plus, and oxygen, we know, is always 2 minus. Think about how many of each do you need to make a neutral compound overall. So a trick behind this is you could swap the charges and pull them down. So if we swap the charges, that becomes Fe2. I'm just ignoring the plus and minus for now. And then O3. And then if we bring the numbers down, that becomes Fe2O3. So we know it's Fe3 plus, so this becomes iron, 3, brackets, Roman numerals, and oxide. Next, you've got to balance the equation for the reduction of Fe2O3 with carbon monoxide. Now, I would say the easiest thing to do is start with the iron, because that appears once on each side of the equation. So you got 2 over here, so 2 in front of this Fe. Then you can balance the oxygen. So on the left-hand side, total oxygen is 4, but on the right-hand side, it is 2. So we put a 2 in front over here. Okay, that would work, and then that means we'd have to get 2 for this. But now that changes numbers, because of the 2 over there, we've got 5 oxygens. So that's not ideal. Let's try it with a 3 and see if that would work out. So you put a 3 over here, that becomes 6 on this side, 3 over here. Well, that would also be 6 because you've got 3 oxygens from here and then 3 oxygens of the monoxide. Question part C is iron compound FeNO33 decomposes when heated. The equation for decomposition of this is shown below. The molar mass has been provided. 4.836 grams of this is heated until it completely is decomposed. Calculate the total volume of gas in decimeters cubed produced at RTP. Now, when you see RTP, that is always going to be moles is equal to volume of gas over 24. Well, it's in decimeters, so we're going to keep that decimeters cubed. Right? Or it could have also had as 24,000 centimeters cubed, but that's sort of irrelevant for now. Anyway, so total volume of gas. Well, out in this equation, we can see we've got 2 areas of gas, or 2 compounds that are gases. Okay, now keeping that in mind, it looks like we could calculate the moles of FeNO33 because we've been given the mass. So the moles of this, FeNO33, would be equal to its mass, 4.836, divided by the MR, which is 241.8. That would be equal to 0.02 moles. Then we could use a molar ratio to see the ratio between that. So we've got 4 to a total of 12 plus 3, so that's 15. So the ratio is 4 to 15. So then the total moles of the gas would be equal to 0.02 multiplied by 15 divided by 4. Yeah, divided by 4, and that would be equal to 0.075 moles. Then we have a moles, we need to work out volume. So volume is moles times the 24. So total volume would be equal to 0.075 multiplied by 24. And that is equal to 1.8 decimeters cubed. It doesn't say to leave it to any significant figure, so 1.8 should be alright. The second half of this video will be covered in part 2. If you did find this useful, please do give it a like and subscribe. Thank you for watching.